these are all the parts that I need for my next project. Well, I hope so. If I haven't forgotten anything, this should be all that I need to make a workshop light, LED light. So these are the light modules I'm going to be using. These are 10 watt each, and I'm going to mount them on this heatsink, and hopefully this will be enough to light up my workplace so I can see better and I don't depend on the electricity in the building. These are the batteries I'm going to use. These are 2.5 amp hours lithium cells. I'm going to be using 8 of them, and actually I'm going to be using them 4 in parallel and 2 in series, something like this. This is the balance board. This is the 2S balance board that I'm going to be using to balance the cells while charging and discharging. This is the basic on-off latching switch. It stays on when pushed and it releases when I push it again. This is the step-down converter, and I'm going to be using this for charging the lithium cells with balance board and with this little trigger board. This is called a USB-C power delivery trigger board, which means when you power it up with another USB-C power delivery capable device like this, and with this button you select the voltage output. This battery bank can output different voltages, like for example it can output 5 volts, 9 volts and 12 volts. And I'm going to be using the 12 volt function of this power supply to charge up my 2S battery pack, which is going to be around 7.2 volts nominal, and I'm going to step the 12 volts down with this DC to DC converter. And this is the step down module, and this is the step up module. I'm going to convert the 7.2 volts back up to almost 12 volts, and I'm going to limit the current so I don't burn out these LEDs. And this is just an ordinary battery tester. It is meant to be used with 2S battery packs like this. It just reads out the voltage and puts the percentage right here with these LEDs. I'm going to use this to make my battery pack. This is the nickel strip. You should actually spot weld this, but I ordered my spot welder a few weeks ago and I'm still waiting for delivery, and I don't want to wait anymore, so I'm going to solder these nickel strips to my batteries, which is not recommended because you don't want to overheat your cells. But if you're fast enough, if you have a hot enough iron, I hope I do, then you are going to be just fine. I already done that a few times and it worked out without any problems. So let's try to hook something up, and I'm going to show you how this all should work. First of all, I want to make my battery pack. These are brand new battery packs. I bought them because they were cheap. They were never used, but they were in a pack already. They were disassembled and I bought them for really cheap price, but they have spot welding marks, but that shouldn't matter for my project. I'm going to put some solder on the nickel strip first. Then I'm going to put some solder on the batteries themselves, and I'm going to bind them together with some heat. I'm using the biggest iron tip I have, and the soldering iron is cranked to the maximum. And now I'm going to flip this nickel strip like this, and I'm going to apply some heat and melt the two solder points together. This is one connection done. As you can see, it is really strong. I don't want to rip it apart, but you can trust me on that, it is pretty strong. Now I need to do the same on the other side, but remember, this side is a little bit tougher to solder and you just need to be quick and put a lot of heat in there. And there we go, this is our first parallel. I just need to make 3 more of these, and I left some tabs here so I can easily weld some wires on it so I don't heat up the battery. And the battery is actually pretty cold because my soldering iron has a pretty good thermal mass, so it transfers heat really good and quick, which is important if you want to do this. Okay, I have soldered my wires to each battery parallel. I have put some wires on the plus and minus side of the battery, and I'm going to cut them as much as I need to make it compact. I'm going to put these two battery parallels in parallel, so basically I'm just going to put them like this, but I'm going to flip it so it lays flat. I'm going to remove the red wire because I don't need it now. And there we go. All the contacts are isolated. I only have 2 wires sticking out, plus and minus, and I'm going to make another one of these. And there we go, I have 2 of these battery packs now. This is my heatsink. The LEDs are going to be mounted on the heatsink, and my batteries should end up something like this. Okay, the electronics should go on the heatsink. This heatsink won't get too hot because it is overkill for these LEDs, but you can't run these LEDs without a heatsink at all, so it won't harm putting these electronic circuits on the heatsink itself. It won't get that hot. And this is basically how it should look, something like this. And when I connect it all, I'm going to make a case for the, okay, something like this actually. I'm going to be using this piece of rubber on top of the aluminum fins. It is pretty thick, I think it's around 2 millimeters, to isolate all of these circuits on this board. Something like this. I have connected my battery pack to the balance board. So this is the plus and the minus of the series pack, and this is the middle point in the series, which is connected here in the middle. My output is now here, and I'm connecting the output to the switch, and from the switch I'm going to power this step up converter, and step up converter will feed the power to the LEDs. Okay, this is how it's going to basically go. This is the power button. This is the capacity checker. It is on the 25% because when you buy these new, they are shipped almost empty because they can't stay full for too long. So basically I wired my battery pack to the battery management board. From the board output I wired my switch, and from the switch I wired to this step up converter. Basically I switched these two. This is actually the step up, this is the step down. I will use these two for charging. And from the step up I'm going through my power meter to the LEDs. This is only temporary. I'm going to set the current limit so the LEDs draw only 20 watts. So let's see. And I hooked the LED up. We can see that the board is powered on, the LEDs are shining really bright. And with these little screws, this is the constant voltage potentiometer, this is the constant current one. And with the voltage I raised it basically above 12 volts, and with the current potentiometer I raised the current to the point where LEDs draw only 20 watts. So this is basically 20 watts now. And it is really bright, and I'm going to show you how bright it is in a complete darkness. Now I'm in a complete darkness. This is the only light I have, and this is the store-bought workshop light, and it's not bad. As you can see, the camera is adjusting for the darkness, but it's not bad. Let me turn on the new LEDs. And look how much brighter is this. Look, this is my ordinary work light. And I can almost see everything in this room without a problem. This is pretty good, and the color is also good. It is more on the yellow side. It is warm white light, but it's great. You can see everything. These are the LEDs, and this is the board. You can even see the board, and the LEDs are under the table, and you can even see the board, how much light this produces at 20 watts. Here you can see my garage pretty good and all my tools. Now I can add the charging circuit. So the step down regulator will go here, and the USB-C power connector will go somewhere around here. Now I'm setting up my charging circuit. This is the step down circuit, and for the input I'm using the ordinary 12 volt power brick, which is the same voltage as this USB Type-C input here. And I want to adjust the output voltage to the maximum charging voltage of the lithium cells, which is 4.2 volts per cell, or 8.4 volts in series, like my battery pack is connected. So as you can see, we are at 9.26 right now, and I'm going to decrease the voltage to 8.4. There we go. This is the voltage at which the battery pack will stop charging, which is pretty important. And now I want to connect my battery pack and adjust the maximum charging current. As we can see, we are at the 2 amps right now. Since I have 4 battery cells in parallel, I can charge up to 4 amps, but my power supply that I'm going to use won't allow that actually. You can see I can increase the current, the charging current now, because I'm using the power brick, but when I'm going to use the USB battery charger, I'm going to have the maximum charging current of around 1.5 amps. Actually, it says it right here. Power delivery at 12 volts, it will be 1.5 amps. So basically I could leave it at 2 because I'm using the lower voltage. Actually, I'm going to leave it at the 2 amps for now. I'm going to adjust it later. So yeah, my battery pack is now charging at around 14.3 watts. And when the voltage reaches 8.4, this circuit will stop charging the battery cells. So the charging is working properly now. All I need to do is connect this inside of my power brick. I have put a small diode here so my batteries won't backfeed this circuit. You can see, if the diode wasn't here, this circuit would be always on power, and I will put this piece of heat shrinking tube over the diode to protect it. And this is it for this circuit, guys. We have our battery pack, we have our input charging power delivery plug, we have power button, our charging indicator, we have our step up circuit for powering these LEDs, we have the step down circuit for charging the batteries, and we have our battery management system here, all combined in one singular package. And the LEDs will go right over here like this, and as you can see, this is how it's going to look inside the case. I need to tidy up these wires, but I'm going to do that later, because first I need to make a case for this. This is going to go something like this, and this is the most compact I can get it, I think. So let's take some measurements. It is 5 centimeters thick, and it's 17 centimeters wide, and around, let's say, 11 centimeters tall. So let's put this aside for now, and you can join me in the part 2 of this build, which is going to be making the case, the enclosure for this LED work light, with some sheet metal welding and a lot of grinding, and finishing this project up. Thank you guys for watching, and I'll see you in the next one. Remember to subscribe, hit that like button if you liked the video. I will put all these parts in the description, and I will put some kind of drawing how I wire this all up on the screen. So yeah, hit that subscribe button, like it, hit that notification button, and I'll see you in the next video. Bye!